So we're here at the example table, and in this video we're going to talk about forms of limits. So let's start right off with an example. So let's look at the limit as x approaches 0 of sine of x over x. Well, as x approaches 0, the numerator approaches 0 and the denominator approaches 0. So we say that this has the form 0 over 0. So we've split the expression in the limit into two pieces. In this case, it's a ratio of two functions, and we look at each limit separately. So we look at the limit of the numerator and the limit of the denominator. And in both cases, there's 0. So this has the form 0 over 0. Let's do another example. So the limit as x approaches 3 of 5x over 7x. So this has the form, well, what form does it have? The limit of the numerator as x approaches 3 is 15, and the limit of the denominator as x approaches 3 is 21. So this limit has the form 15 over 21. So let's now look at one more example. Let's say the limit as x approaches infinity of natural log of x all over 1 over x. This has the form what? Well, natural log of x as x goes to infinity goes to infinity, and the thing in the denominator is going to 0. So this has the form infinity over 0. So let's look at a few more examples. One of the things we're concerned with is when a form is determined or undetermined. And informally, a determined form is one that will tell you what the limit equals even if you don't know what the particular expression is. So let's look at an example of that. So suppose that we have the limit as x approaches infinity of this expression that I'm writing now that I'm not going to let you see. So I'm writing down the limit of something, and I'm going to tell you that this has the form 1 over infinity. Now, still without knowing what this particular expression is, you can know just from the form what the limit equals. So thus, this limit is 0, because you have something in the numerator that's approaching 1 and something in the denominator that's getting ever larger. And when you divide something that's close to 1 by something that you can make as large as you want, you get something that's really small. In other words, the limit is 0. So now, if we reveal what this function is, we see that it's 1 plus 1 over x all over e to the x. This has the form 1 over infinity, and the limit is, in fact, 0. But we didn't need to know this particular expression to know what the limit is. All we needed was the form. Let's look at another example. So let's suppose that we have the limit as x approaches infinity of something. And again, I'm not going to show you what that thing is. So we've got this limit of something mysterious, and I'm going to say that this has the form infinity over 3. So what is this limit? Well, we can tell just by looking at the form. We have something that gets as large as we want in the numerator, and then something in the denominator that's getting as close to 3 as we want. Well, if we take something that's really large and divide it by 3, we get something that's still pretty large, because remember, we can make the numerator as large as we want. So this limit is infinity, for the reasons I just explained. Now we can reveal what this expression actually is. It's the natural log of x over 3 minus e to the negative x. and we know that this limit is infinity. But we didn't need to know this expression. All we needed to know was the form. And this can be pretty useful because at first glance this might look like a complicated expression. But if you see that the numerator is going to infinity and the denominator is going to 3, the fact that this happens to be the natural log of x and minus e to the negative x and all that stuff doesn't really matter as long as you can identify the form. Let's look at one more example. So let's look at the limit as x approaches infinity. And notice a lot of the examples we've been doing have been x approaches infinity. That's not a requirement. Two of the examples at the very beginning, x approaches 0, x approaches 3, doesn't have to be infinity. So the limit as x approaches infinity of something. Once again, you're not going to see what this something is, but I'm going to tell you what the form is. I'm going to say that this has the form 0 times infinity. So this means that this expression here that you can't see is made up of two functions, one of whose limits is 0 as x approaches infinity, and the other limit is infinity as x approaches infinity. Can you tell me what the limit equals knowing only the form? Well, the answer in this case is no. So if we reveal what this particular expression is, we can figure out what this limit is in this case. The expression is 1 over x times x squared. This simplifies to x, and x goes to infinity as x goes to infinity. But what if we change this expression? What if we look at the limit as x approaches infinity of 1 over x squared times x? This has the same form. 1 over x squared is going to 0, x is going to infinity, same form, but this is the limit as x approaches infinity of just 1 over x if we simplify, and this is 0. So in the first case, a limit of the form 0 times infinity has a limit equal to infinity. In the second case, the limit of the form 0 times infinity has a limit of 0. And you can get lots of other results as well. In other words, if all you know is that this limit has the form 0 times infinity, then you don't know what the limit is without further information. So you need to know what the particular expression is. This is what we call an undetermined form.